This presentation will review the Georgia Standards of Excellence 2 G3, which states that students will partition circles and rectangles into 2, 3, and 4 equal shares. Describe the shares using the words halves, thirds, half of, a third of, etc. And describe the whole as 2 halves, 3 thirds, 4 fourths. Recognize that equal shares of identical wholes need not to have the same shape. First grade students are introduced to the concept of half and quarter as they partition shapes into equal shares. Second grade students then explore thirds and how shapes can be partitioned into same-sized pieces but have a different shape. The pieces in these brownies represent the same area, but they do not all have the same shape. Each brownie is divided into half, and then each half is divided in half again. Each section represents an equal share of 1/4 of the brownie. As students build conceptual understanding of partitioning shapes, geoboards can serve as a great tool that allows students to explore partitioning rectangles as well as circles into halves, thirds, and fourths. The upcoming videos highlight several students partitioning rectangles and circles in different ways. Okay, so we are going to talk about dividing a rectangle or square into fourths. What does fourths mean?
Fourths mean dividing one whole thing or object into 4 equal parts.
Okay, so we made some designs and they all are divided in different ways. And I want you guys to tell me, like, is this one divided into fourths?
Yes.
How do y'all know?
Because like, there's 4 squares, there's 4 slots.
Are they the same size?
Yes.
Okay, so let's look at this one. What about this one? It's divided differently. Is it still divided into fourths?
Yes, it's just all triangles. It's just triangles.
Yeah,
They're all the same size.
So that's a fourth and the other's a fourth, even though they're different shapes?
Yes.
Okay, what about this one right here?
Yes.
Yes. Well, let's look at this one. Is it divided into fourths?
No.
No? How do you know?
Because these 2 are squares and these 2 are not the same.
Okay, well, let's count how many squares would be inside of the square, like little squares. How many would be inside?
2, 3, 4.
Okay, how many would be inside that one?
4.
How many are inside this one?
4.
How many are inside this one?
4.
If they're all 4, are they equal?
Yes.
So, is that divided into fourths?
Yes. But
So-
different ways. These
Yes.
2 are squares and these 2 are.
So do they have to be the same shape to be divided into fourths?
No.
Your geoboard make the largest circle possible. And then I want you to divide that circle into 2 equal parts.
Dad. Ooh, that's easy.
Yeah. It was easy to divide it into halves. Is it a little bit harder to divide it into thirds?
Yes.
Yes.
Kind of.
Do you think your pieces are equal?
Yes.
So this one, it curves and cuts out, but this one's taller, so do you think they're equal?
Yeah.
You do? Okay, are your 2 top parts the same size as your bottom part? No? Let's keep trying and see if we can make 3 equal parts. So let's put a rubber band in the middle, peg, and go to 1. And let's try to go around with another one. Well, let's try to make it a little bit bigger and see if we can make 3 sections that are the same. Yes, that was fourths, but let's try to make it into thirds. Maybe a little bit bigger than a fourth. How many pegs do you have in between?
1, 2, 3.
Okay,
It's just sort of
count
fun.
1, 2, 3, and then put 1 here and see what happens.
That's 4.
Okay, look at hers.
1, 2,
Look
3.
at this one. How do you know they're equal parts?
Because they're all the same size, and if I count them, 1, 2, 3, they're all
They're all thirds, and they all have the same number of pegs in between, so they're all equal spaces. So explain your different representations.
So this is in halves, like straight down,
Okay.
and the second halves is straight in the middle that goes straight.
How many equal parts do you have in halves?
2.
Okay. Explain this one to me.
So how you make 3 halves
Or
is
not 3 halves, but they're divided into
3
thirds.
thirds.
You have 3 thirds.
3 thirds. And I did straight down into the middle where this one is, and then I did another line to this one. Then I did another line to this one to
And
make
are the
thirds.
pieces equal?
Yeah.
Okay, and what are these two pictures represent?
Fourths.
And so are these, how many equal parts do you have in fourths?
4.
Okay, are these equal parts?
Yes.
Can you count the spaces in between to see?
1, 2, 3, 4. 1, 2, 3, 4.
So those two are equal. What about this one?
1, 2, 3, 4, 5.
And what about this one?
1, 2, 3, 4, 5,
I'm not
6, 7.
done.
So is this one divided into fourths?
No.
No. But you can fix it, right?
Yes, you can.
As the video showed, partitioning circles into equal shares can be quite challenging. Simply rotating the partitioning lines often makes it difficult for students to create equal shares. And while it is possible to create equal shares with lines going from side to side, determining if they are equal by simply visualizing each section often leads to inaccurate results. When you cut your circle into 3 equal parts, you have one section rolled up, and now let's roll up the other section, and we'll see if it's the same size ball. Okay, now let's roll up the last section. Do you think it's going to be the same size?
Nope.
You don't? So would it be equal thirds after you compare? Let's put all 3 balls together. Put them together. Do they look like they're the same size?
Nope.
No. Did yours come out close to the same size?
Kinda.
Yes. It's hard to still tell. Additional errors and misconceptions that often occur when partitioning shapes include counting the partitioning lines instead of the number of equal spaces. In the second example, it is easy to see that the rectangle is divided into fourths because each triangular piece is the same shape. But in the bottom example, students may have difficulty determining if the pieces are equal because the triangles have different side lengths. Additional hands-on models should be used to help students conceptualize this concept. So if you're cutting the cake into fourths in 3 different ways, what's a different way that you could cut the cake into 4 equal pieces?
That's not really equal.
Well, if you drew a line the other way, could it be equal? Let's see. See what happens. Is that piece the same as that?
Well, that one's larger than
Okay. So when you cut this one down the middle, what did you discover?
that. If you put that together like that and that, it makes the shape.
It's the same size. So this triangle is the same as that triangle. So is this one divided into equal fourths when you go from diagonal to diagonal? Yes. You need to fold your rectangle in half. And then I want you to turn the paper and fold it in half again. Okay, now open it back up. Is your paper divided into fourths?
Yes.
Okay. Now what I want you to do is take this top half and fold it in half to the middle. So take it to the middle line and fold it down in half. Okay. So now let's open it back up. And what I want you to do with a crayon is draw a line right down the middle. Now draw a line from here to here. Now trace this crease. And I want you to cut out on the lines that you've traced. Your 4 pieces, do you think they're divided into fourths?
Yes. No.
Wait.
Okay, let me see. Why do you think it's not divided into fourths or 4 equal pieces?
Because these 2 are not equal. Because this is not equal.
Well, what if you cut this one in half? Cut that in half and see what happens. Okay, and now what do you think? You put them on top, are they equal? So this side piece is a fourth, this is a fourth, this is a fourth, and this is a fourth. How many fourths make a whole?
4.
When partitioning shapes, it is important to provide problems in context. A 3-act task is a whole group mathematics task consisting of 3 distinct parts: an engaging and perplexing Act 1, an information and solution seeking Act 2, and a solution discussion and solution revealing Act 3. In Sliced Up, Act 1 consists of a video that shows the bowl being filled with orange slices. Students take note of what they notice and what they wonder. They then think of a question that they may have about the video or picture that they were shown. For example, a student may ask, how many oranges were cut up? Students then make an estimate and decide what information they need in order to solve the problem. For example, how many slices are there and what size is each piece? As students ask questions, clues such as each wedge is a quarter of an orange or that there are 20 slices in all can be revealed. So what did you wonder after watching the video?
What size are the pieces?
And what's your main question?
How many oranges are there?
So how many total oranges did y'all find out? There were
5.
5, and how did you do that?
Because when we counted, we counted 20 of them, then there was 20, then we add them together, we saw there was 5.
Okay, how many quarters are in each orange? 4. So when you have 20 slices, how many holes did you make?
5.
You think there's going to be 5 oranges, right? Tell me why you think that.
Because 4 plus 4 equals 8, and 8 equals 12, plus 4 equals 16, and plus 4 more is 20.
Okay, so you added 4 over and over until you got to 20, and then you figured out that you had to do that how many times?
5.
5 times.
So what did you draw on your paper?
20 slices because there was 20 slices, and I circled 4 because 4 equals a group. And
So how many oranges do you think there are in all? So how many total oranges are there?
5.
Good job. The banana split party task adds additional rigor. Miss Penrod's class has 22 students. In order to make sure she knows how many bananas to buy, the students must partition the bananas into halves, thirds, and fourths. If the bananas are cut in half, how many should Miss Penrod buy?
She should buy 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 bananas.
And how many pieces does that make?
2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22.
So is there any banana pieces left over?
No.
How many bananas will she need if she cuts the bananas into thirds?
She will need 1, 2, 3, 4, 5, 6, 7, 8 bananas.
8. Will there be any
7
left
and
over?
7 and 1/3.
7 and 1/3, so you have some left over. How much is left over?
2/3.
Okay. How many pieces are there in all if you have 8 bananas?
3, 6, 9, 12, 15, 18, 21, 22.
24. So then you had 21, 22. You don't need those last 2 pieces. The bananas are cut into 4 pieces. How many bananas do you need?
6.
Will there be any pieces left over?
Yes.
How many?
2.
2 what?
4th.
2/4. For additional tasks and resources, please check out Unit 5 and the Georgia Frameworks.